Hey guys, and welcome back to the Blonde Zenith Restoration Project. I'm going back through and replacing the remaining paper caps. Got the set working fairly well on mostly original parts, but I do want to replace these guys. Now, I spent a lot of time talking about restuffing the plastic caps. I think I will restuff some of the bumblebees and install them, but there are very few. Most of the caps are this gray plastic type. There's maybe like 6 bumblebees, and the rest are these guys, which I'm not going to attempt to restuff. I don't really think it's feasible unless you've got some very nice equipment that can slice and dice and hollow them out. So I'm just going straight with the black caps. I'll save these someday, because I plan on keeping this set for a while. I may go back through it, but if I can't restuff, refurbish all the caps such it looks like nothing was done to this, I don't see much point in doing like half of them. But all these yellow guys I tacked in while we were troubleshooting, those are all going, and I'll replace them with the black guys. But what I also want to do is try out Hakko FR-301 desoldering gun. I've been using it on a few other projects, circuit boards mostly, and I did some tests on terminal strips, but this will be the first time trying it on an actual TV that I'm actually working on right now, and not just screwing around and doing some tests. So let's try to remove the solder from that lug. Because I haven't been using J-hooks when I've been putting these caps in, I've been cleaning up the lug, removing the traces of the old wire and installing them. Used some solder wick when I had to, otherwise I've just kind of been working, heating it up and using needle nose pliers and unwrapping leads. But let's see how it goes with this guy. So I'm just heating it up on this side. Yeah, it's melting pretty quickly. Wow, that worked better than I thought it would. So these are terminal strips that have holes that go all the way through. I think you can see now that we have daylight. So it darn near removed every bit of solder. There's a little bit on this side left, but I'm not taking that resistor off. I want to take that lead of that cap off. So I don't care so much about getting all the solder out in front. I want to get it all out in back. So let's get after this. Again, oops. Yeah, it's not really melting so well. It's a problem with doing that. Okay, now it is moving the lug around. Alright. So now let's see, can I just remove that without doing any more heating to it? My big concern with using this, because these are self-contained, the vacuum pump is in the handle, everything's here. It's a little heavy, it's a little big, so I see in some tight quarters it may be a little hard to use. Like if I wanted to get down deep in here on this tube socket, that seems difficult. Or if I have to go in from the side and not straight in, like getting in from near a transformer up against the side of the chassis, I think it's going to be a little tough. But for the most part, I'm going to try this guy too. Yeah, I think from the bottom would be best. Yeah, see, that's kind of it's a little big and clunky and heavy. Sometimes slip, but I'm trying really hard not to melt any wire insulation, because this entire metal bit, those 4 inches or so on the left, is all very hot. So when you're getting in here, I do not want to touch any of these wires with any of that shiny metal you see there. So like in here we got a bunch of wires, we got this coax, and I'm getting in right next to it. I try going from this side, but there's kind of parts in the way. They do sell nozzles with bigger ends, but I'd need something that had like a 1/4 of an inch opening to slide it over an entire terminal strip lug, so I don't think we have any choice but to go in from the side. What I may need to do on some of these is feed a little fresh solder in. Oh, it's going to get good thermal contact. So that one's got a little bit more going on, and I wasn't able to get in there as well, so I don't think it worked quite as well. But let's get back to this guy and see. So we want to get this out. And I think didn't quite get all the solder out, so it still held in there, but I bet a little bit of force. Yeah, it just popped out. It's just a hint of solder still holding it in place. Yeah, it's free. So to me, the advantage, yeah, I could have done that pretty readily without using the desoldering gun, just by heating it and wiggle it back and forth or clip it off, get some metal fatigue and get it out. But when I put the new part in, the lug is opened up so I can slide it right in, wrap it around, and solder it. I see that being a big help. Let's go after this one next. This I'm kind of curious about because it's on the ring around this tube base. It holds it in place. We got some wires going in there, so it's going right to the chassis. This is all ground. So it's going to, I need to heat that up pretty well to get the solder out. There are 4 temperature ranges on this thing. I'm using the lowest one. I might want to go up a notch to try to get something that's near the chassis. Occasionally, like on these twist locks here, we got a big blob of solder going right to the chassis. I'd be impressed if I could actually remove that. But I can give it a try. Let's do this next because we got that's the other end of this cap. And there's another one hiding behind it I want to get, so they're both going to that lug, so I want to get both of those off. So in the past what I would do is I would go in here and cut these ears off and then heat up this joint with one hand, needle nose in the other, and just kind of poke around, work at it. Use desolder braid if I needed to. I already know I got to take these out, and it's only 2 things going there, and they're both coming out. So I'm going to give a little bit of help before I even bother with the desoldering, and just clip these. So it's not like working on a circuit board where you suck a little bit of solder and the part falls off. The wires are wrapped around lugs. You can remove all the solder and the part's still there. So you have to use multiple tools and to completely remove everything and clean out those old lugs. I played around with it a bit more, did a few more terminal strips. On the lug down here, it worked okay, but not great. It turned out there was actually a 3rd wire going to it, so between those 3 wires, it was pretty much filling up this whole hole here. So when I heated it up, it got the solder out. All 3 wires are still firmly jammed in there, so it was more of a mechanical issue than electrical. Then I went after this lug, the other end of this cap, and pretty well got it all off, but just like down here is a little bit of residual solder that's left. I think that's every lug that I've done. That's been the problem. That's not really a problem. You're just not going to get it 100% out. So you may have to reheat it or wiggle things a little bit to break them loose. But yeah, I mean, it's always gotten the eyelets wide open. So when I insert the new part, it's already prepped for it. So do I recommend a desoldering tool like this? Well, it depends what you're going to work on. If you're only going to work on old radios and TVs with wiring like this, probably not. But if you occasionally or primarily work on circuit boards, yeah. Especially it's it's very gentle on the old phenolic types. Boy, this set has taught me to trust nothing. I was wrapping up work in this area, replaced this 0.047 microfarad cap down here, and I was double checking it against the schematic, make sure I got it right, and I noticed there was a second one on the schematic, another 0.0047. In fact, 2 of the ends are connected together. And I looked at the SAMs, and it showed 2 tubular paper type looking caps in that area, but in mine, one was tubular, like those gray guys I've been taking out, one of these, and the other one looked like a mica cap. So I just got out my cap bridge, disconnected one end, got it clipped in, went to check for leakage, and it's leaky at the lowest setting. It should be good, if I'm reading this right, for 500 volts. So that's another paper cap hiding as a mica. And that one's rather small, so you know, it's about the same size as these guys. Man, I think I should check the schematic, and anything that's 1,000 picofarad or greater, clip one end out and test it. I'm trying to check for the value. It's indicating short, so I can't even check the value on it. That is one very, very bad cap. Now the set's working pretty well, so the reality is I don't expect much change at all as I replace the last few paper caps. What is the last remaining major defect is bad vertical and horizontal linearity, which is not going to be affected by the remaining paper caps, which are mostly in the audio and IF circuitry, few and sync circuit. Not going to affect linearity. What is left is some electrolytic caps. We got one down here. I'm not sure what that one is. These two, which are on the centering controls. Some higher end sets have controls that vary a DC bias current in the yoke windings, so you can do centering with potentiometers rather than fiddling with magnets. Those aren't going to affect linearity. What will are the other electrolytics. In fact, there's 4 multi-section can electrolytics. Now let's go after the vertical first, because it's odd. It's scrunched at the top and the bottom and stretched in the middle. Now that is the vertical output tube. It's a 6V6. There's a cathode resistor, partly fixed, partly variable, and that's what you adjust for the vertical linearity. Now that's bypassed with an electrolytic capacitor, and that is the #1 cap you should replace if you have vertical issues, like no vertical deflection or it's compressed at the bottom. It's very likely going to be that cap. Now there's a multi-section electrolytic right next to that tube, but that's not where it is. And we got 3 in a row down here. Of course, it's the one that's the absolute furthest away. Furthest cap and furthest section in that cap. That's bad engineering. That's why if I didn't care about preserving originality, I'd probably tack the cap right on the cathode pin of that tube. It goes from the cathode to ground. Having a long wire snaking all around, add some resistance, add some capacitance. Regardless, that's where it is. Now you may notice it's disconnected because I was getting all set to pop it out, cut it open, restuff it. And I got to thinking, hey, my original intent was to try to reform these caps. So once I had it isolated, I hooked it up to the capacitance bridge, and you know what? It's us all right. We don't have excessive leakage on any of the 3 sections. The only issue I've found is that the ESR, or power factor, is a little high. Power factor is about 7%. I'd like to see it down to 2 or less. So it may be an issue. What I'm going to do is hook back up the other 2 sections and tack in a new cap for that cathode bias and see if it makes a difference. Or cathode bypass, I should say. If it doesn't really make any significant difference, I'm going to wire this back in and keep it in the set. Now, what will potentially happen down the road, especially with high ESR? Internal resistance. Resistance times current equals heat. So when you've got a lot of ripple current in a cap and it's building up internal resistance, it's going to generate internal heat, which will just cause a runaway effect eventually. where the heating will cause the capacitor to degrade, which will make the internal resistance go up higher, which will make it get hotter, and so on until it vents. So I'm going to leave these original caps in here. I don't want to leave the room, leave the set on unattended, because the last time I did that, you may recall, last year, a cap vented on me. I don't want to have that happen again if I can possibly avoid it. So yeah, we'll commence to doing that, but before I do that, I got to finish up a little bit of work I was doing on some of the paper caps. I'm just about done replacing all the paper caps and the yellow caps I had tacked in temporarily earlier. I just noticed I have one left I missed up there. Now these two yellow caps over here, I don't have a choice. That one needed to be rated for 1,000 volts or better. They don't sell the black ones at just radios at that high a voltage, so I had to use one I had on hand. And that's an oddball value a little bit, 0.033, and they didn't carry them in that value, so did what I had to do. This Bumblebee and this Bumblebee, they have new caps inside. And the interesting thing about this technique, when you split them open, you got two halves. This cap, I'd already installed the new cap before I put it inside a Bumblebee shell, and I just cleaned out one, put a little glue on it, and just squeezed it over in place. The glue sets up real quick. I'm just using super glue. And that's that. In other words, you can do it later on if you care to. So that's why I split these open. I'll hunt around and find caps that are this value that I can get at, and I may or may not install a few more of these. Been splitting them open with the straight razor, get a nice sharp one, a few taps and a hammer right on the seam. Seems to work pretty darn well. None of these were split open. A little bit of incidental fracturing on some of them, but if you're careful when you glue it up, that won't be a problem, or well, simply rotate it so you don't see the bad seam. And to clean them off, denatured alcohol. That's why this one's all nice and shiny. Don't do it too crazy though, you'll wipe the stripes off. They're just painted on. Cool thing about it, even leaving those black caps in, I've seen plenty of undersides of chassis, but if I was to just casually glance at this, I wouldn't think any work had been done. One thing that might clue me off a little bit is some of these parts look a little too clean, like a new resistor here, or that I cleaned off these Bumblebees. So depending on how authentic you want to be, you might not want to clean them. You might want to leave them a little grungy looking. But these black ones I like, especially the ones that are black on the ends as well. Some of them are white. And yeah, of course I could take a yellow cap and spray paint it black if I really wanted to, but just trying stuff out, trying to keep the hobby interesting. I always like to try new things. I went ahead and replaced the last few remaining paper caps, and I tacked in a temporary replacement for the vertical output tube cathode bypass cap. And you know what? None of that really made any difference. Well, I kind of figured it wouldn't, because I tested that electrolytic cap and it tested okay. And the last few paper caps were not in the vertical or horizontal deflection circuits, so I didn't really expect much. But we still have issues. So vertically, the squares are taller in the middle and squish at the top and the bottom. I'm adjusting the linearity control, and I can't, I just can't get it right. So the height control, and the two interact, and I can get it better, but I can't get it quite perfect. And even if I get it pretty darn good in this one, this is normal viewing mode, this is porthole mode, it's supposed to fill the whole screen. And it kind of does, but the linearity's crummy. Should be better than that. And then horizontally, we still got width issues. It's almost filling it all the way, but it's still really crushed on the right. So we got more work to do. So it's not going to be just as simple as replace all the paper caps and we're done. We got a little bit more work to do. Now, of course, there are more electrolytics. I had disconnected this one, tested the suctions, they had acceptable leakage, capacitance was within the range, the capacitance value was acceptable. But there are 3 others. There's one there, and there's one up there. I have not tested those yet. So that's going to be it for now. When we pick up, we'll replace those. We'll test those remaining electrolytics and replace them if need be. But so far, I'm happy. This set is really coming to life quite nicely. We just got a few remaining issues, and that's the way it usually goes. Getting 80% or so of the way there is generally pretty straightforward. It's that last 20% that can really give you some headaches.